Good afternoon, everybody. As we get started, I'd like to acknowledge my two co-authors, Aaron LaRoche and Paul Zeal. Aaron with Pivot Engineers and Paul Zeal with the University of South Carolina. And I am going to try as much as possible doing what we learned about yesterday, positive hand motions. And if I see any motions from Aaron about cutting me off, I'm going to wave them off. What I'm here to talk about today is the changes in the load testing requirements that are present in the ACI 318-19 standard. And it's an example of what we should be doing more of, integrating and coordinating different ACI committees towards a common goal. Brief overview of the presentation. Let's talk about some ACI 318-14 load testing requirements, where we started, and then go way back in the Wayback Machine. Talk about some of the historical ACI load testing requirements, and you see they didn't change much. What we did to ACI 318-19, and it was nice to see Brian showing all those ACI 318-19 requirements, showing the current requirements. So what are the changes and how do we get there, and what's the future hold? So to understand the changes, it's really helpful to look back at where we started. So this is the load testing requirements of ACI 318-14. It's pretty simple. You can see the loads compared to what Brian showed were slightly different. 1.15 dead, not splitting, superimposed, and self-weight dead loads. 1.5 live loads, now 1.6. The load testing procedure was monotonic, as Brian had talked about. You put the load on in 4 increments, you measured displacements, kept it on there for 24 hours, you looked at recovery. And the acceptance criteria, there's basically 3 of them. In simple terms, don't break the structure, keep it as simple as possible, a maximum deflection criteria, or a deflection recovery criteria. That's the basics of it. There's also the requirements if you want to do an additional test, a couple other smaller requirements, but you're basically looking at the deflection of the structure and the condition of the structure when you're done, and don't break it. Shown in the actual text, in the small text, those are the actual requirements from the 1963 acceptance criteria. If you read through them, they're exactly the same as ACI 318-14. They're exactly the same acceptance criteria. So they're really, they're basically unchanged in the last 50 years. That's 12 code cycles. There's some minor changes in the wording. The test load magnitude changed a little bit. It's typically about 85% of the design load. Some discussion was added regarding shear, but really we're talking about an equation and an acceptance criteria that didn't vary for 51 years. Now compare that to things like, let's say development length equations, which, personally I think the development length equation code, they got new development length equations in there. That's how fast they change. And what actually changed is this is actually the longest serving, this has been the longest serving equation that's appeared in the ACI code, as far as I could tell. There may be something else, but I don't think anything else has lasted 50 years, and it's gone. And it's interesting to look at this term, this L squared over 20,000 H. It's kind of mysterious. 20,000, how'd you get such a perfect number? Kind of look back at the origin of that a little bit and went back even further into the ACI time machine, look back at the earlier load testing requirements. So, as I mentioned earlier, ACI's really had load testing requirements since they started making building codes, which is 1936. 1941 was the first time it was called 318. And if you look at the acceptance criteria shown on the screen, it's almost exactly the same as the 1963 code. The only difference is that little L squared over 12,000 H. So basically we had equations in ACI 318-14 that have been almost around, almost the same acceptance criteria for getting on like 80 plus years. It's pretty amazing. And this L squared over 12,000 H is interesting. And a former colleague and an ACI, great ACI person, Tom Ruertz, came up with a derivation of it. And if you're interested in like simple equations and where it comes from, there it is. You can turn those equations into L squared over 12,000 H, pretty simply. A little bit of a quick derivation. And for people that are recognizing the mechanics of that, that's the deflection of a uniformly loaded, simply supported beam, moment, WL squared over 8, we all remember that one. Sigma is M over S. S is BD squared, BH squared over 6. and some very low stress limits and allowable stress. And that's the equation that's been used as an acceptance load for load testing. Somehow in 1963, there was a change in the allowable compressive stress, and that's pretty much how we think they got to L squared over 20,000 H. But no one really knows. It really wasn't that documented. So that's going back into the time machine. So what do we know? Our monotonic test is nearly 100 years old. It's considering very simple, simply supported flexural behavior, quasi-elastic, sustained load 24 hours. And I'm told, since there's a couple of WJE people in the audience, I think it was Chuck LaRoche told me this, it's actually Pete Popovich there on one side. I don't know if that's true, but that's just what someone else told me. But what's going on with our monotonic test? It's really not thinking much about the response to the structure. It's not thinking about the response to the structure to load, and particularly the unloading branch. And what happens is most structures, we get multiple loads. It doesn't consider this unloading branch much. It doesn't consider the fact that by the way, most of our structures nowadays are continuous. Simply supported structures are common, but a lot of them are continuous. It doesn't consider possibility of shear failure. So a lot of people involved in ACI have been involved with a committee called ACI 437, strength evaluation. And that committee has produced a couple of documents. It's been around for a while. And that committee has predominantly been focused on development of techniques for load testing and how to evaluate the strength of existing structures. And for a long time, they've been telling the people in ACI 318, you know, your load testing equations, the test method improved. And ACI 318 for a long time said, we got this. It's under control. And that went on for a fair bit of time. Finally, and I'm going to talk about, next month, I'm going to make a presentation at the ICRI convention, and it's entitled Punctuated Equilibrium. And that's an example of something that rapidly changes in a short time frame because of a radical change. And that radical change that occurred was the development of ACI 437.2-13. That's a standard load test, a load testing standard for concrete structures. It's a new standard. ACI TAC allowed the committee to develop a standard. Specifically, they wanted to do that because they had some better ideas on how to do load tests. So a radical change by one of the committees, it created a standard for load testing. And you can see some of the requirements in here. 2 procedures for load testing. The monotonic, the one we know that's been around for 100 years. And another one, which is the cyclic, which is a completely new school testing method. And we'll talk about that a little bit, what's meant there. The test load magnitude. It's putting on a full live load. 1.6 live load, and a lot more rational consideration of the dead load. Self-weight dead load, and then some function of the superimposed dead load. The acceptance criteria for the monotonic were very similar to what we saw previously, but it also included an upper limit of L over 180 on deflection. That causes all sorts of problems because people just don't like that. We'll talk a little bit more about that. And it was specifically developed for use with ACI 562 code. Another example of radical change that occurred in a short amount of time. ACI allowed a code committee to develop a code for repair of existing structures. Radical concept, developed it. ACI 562 committee, through the work of Chuck LaRoche, was very aware of this new standard being developed and said, no, that's the one we want to include in the new repair code standard. So not only was the standard for load testing developed, it was adopted into another standard. Talk about acceptance criteria, what's a little bit different. Monotonic test is exactly the stuff that you've seen before. Deflection recovery do not break the structure. But now, on the max deflection, it's L over 2,000 or 0.05 inches. That's, as Brian described, it's a method to not punish stiff structures. It's also a little bit simpler, and it's getting away from something that had no rational basis. It really had no rational basis, plus this deflection limit. For the acceptance criteria for a cyclic load test, this is where it really gets cool. We're actually looking at the response to the structure, and with a load testing, we're actually thinking about, is the structure degrading? Is there a deviation from linear elastic behavior? So we're actually thinking a lot more about how the structure is behaving under loading and unloading. And as I mentioned earlier, this got adopted into 562.13. And let me talk a little bit more about cyclic testing, load testing protocol. I'm sure someone else in the sessions is going to talk about it. That's the loading protocol for unloading and reloading of the structure. You're basically amping up the load in a series of cycles, unloading, reloading, repeating it. So what are we doing? We're actually applying the load more similarly to a way a structure would actually be likely loaded in service. And acceptance criteria. 3 cycles, there's 2 measures. The deviation from linearity, I'm sure someone's going to talk about that in great detail in one of the later presentations. But you're looking basically at the change in the load deflection behavior, and that's considered a measure of damage. When you think about loading and unloading something multiple times, if it starts, or if we're losing too much stiffness, that's considered bad. There's a damage. The measure of damage is the deviation from linearity index. The permanency ratio is a measure of the residual deflection. How much the residual deflection compared to the peak deflection in each cycle. If that gets too big, you get a lot of permanent damage, it's a bad sign for the structure and it fails. And then the overall residual deflection. Now what's the advantage of it? You can do a load test in a lot less time. Full load test in a day, less than a day. You're using a little bit more modern equipment. You've gone from guys with sacks of sand. How come you didn't have any pictures of sacks of sand as a load method, Rumpra? You guys aren't strong enough, or? Next time, okay. Looking at more modern equipment, it's a much more interesting load test. It's a better look at behavior of the structure. But the tried and true monotonic test method is also in there, in 437.2. So, right now in our story, we're at this 2013 period, 2013-2014. We have a ACI repair code committee has allowed, by reference to ACI 437.2, that cyclic testing is now allowed. ACI 318 only allows for monotonic testing. So we have 2 different documents by ACI that allow 2 different methods for load testing. And people on the repair code committee said, we didn't really think that was a big problem. However, public comments indicated that this was a major problem. This one organization, 2 load test methods. That was considered a major problem. And what can be done about it? It's either Houston, we have a problem, or what was actually done is we had an opportunity for multiple committees to get together and actually work on collaboration and how we can move this path forward. So what did we end up with? Where did we get to in 2019? This really started in the fall of 2014, so it took 5 years to get this done. That actually worked out with the cycles. It started with the new fall of 2014. There's a new ACI 318 chair, and one of the things that he started right at the front, first meeting of his new committee, he said, let's get rid of this conflict. The task was assigned to ACI Committee 318-C, which I became a member of. I was also the chair of ACI 562, so it worked out. And we got a lot of help from a lot of people on ACI 437. Got an opportunity to collaborate. And the end result, we produced the changes, some major changes in ACI 318.19. We have now a consistent test load method, changed ACI 318.19 to allow for the same test load magnitudes as 437.2, unified the monotonic acceptance criteria. The L over 180, that little problematic thing, may be waived if the design professional doesn't think that's a problem. And now cyclic testing is allowed by reference to the procedure in ACI 437.2. So, when we're thinking about this ACI time machine, this is a massive amount of change, something that occurred in 5 years that modified something that had basically been present for 56 years. Looking at the audience, the load testing method's been basically unchanged since most of the time that everybody in this room was born. If you think about that. You think about things 56 years ago. What did we have 56 years ago? We barely had FM radio. I don't know. I wasn't even born, so not sure what happened. So how did it happen? How did we get there? First ACI 318 meeting, when this was discussed, somebody said, well, what does TAC think? What does ACI TAC think we should do about this? The guidance from TAC is basically, you guys are big boys, big girls, you guys figure it out. Predominant work was done in ACI 318C, and we balloted 3 different options over a 4-year period. And each time I had to go back and talk with Aaron and Paul about, is this going to work? Let's try this. First option we had was to basically try and fully adopt 437.2 by reference. And that did not work because there was a conflict that ACI 437 was really developed to work with ACI 562, so that didn't work. I then spent about a year trying to incorporate all of ACI 437.2 into ACI 318. That took a lot of work, objections, because there was a massive amount of new text being added. If you think about trying to put a 30-page standard into ACI 318, which is already way too thick, that was a massive waste of my effort. And lack of and it creates huge problems because there's no potential for coordination on future versions. And finally, we worked on modifying ACI team to capture key parts of ACI 437.2. We unified the test load method, we unified the acceptance criteria, cyclic testing by reference. And this, at the second to last meeting of ACI 318, that adoption was finally approved by ACI 318, full committee. It took a long time to work on, it took a lot of effort, but we got massive changes that I think make a significant improvement in the load testing standard. And it also represents something completely new at ACI. This is really the first time that ACI 318 is adopting work produced entirely by another committee. So I think that's a great result in that in the future, all these committees can keep working together. So the big questions, couple big questions coming up. Where can we go next? People are interested. ACI 437, they're working on a new version of 437.2. New code cycles are starting in ACI 318, 562. If you got ideas on if anybody in the audience has ideas as to what can be done to further improve this, let me know, let Aaron know. We're always looking for new ideas on new ways to improve ACI documents, and we really need to keep working together. Trying to figure out what's the best path forward. We're going to start talking about that tomorrow on Tuesday in the 318 sub C meetings. Do we want to just purely adopt 437.2 into ACI 318? Pure adoption by reference, keep it the same? Not 100% sure, but we are going to keep working together. I guarantee it's going to stay in 562. So that's a little bit of where we go next. If you have ideas, please let me know. Some acknowledgements. A key person in this was the ACI 318 chair, Jack Maley. He wanted to get this done. He got it. He basically got out of the way, assigned it to a subcommittee, and that was it. He let people get out of the way, let people do their jobs. Joanne Browning is subcommittee chair for ACI 318. She was basically there 100%, recognized the need to do this. And some of our ACI 437 members, in addition to Aaron, Chuck LaRoche, Jeff West, John Fraunhofer, they did a great job on consistently being sources where I could ask questions, review text, great source of information, and helped us out a lot on this process. So I guess with that, we'll see if there's any questions.
Good evening. Thank you for your lecture. I just want to know, this method, the load test, is made for all types of, let's say, flexural members. Mm-hmm. If it is simply supported, it is for simply supported as a base, or because we do the same procedure for all kinds of the, if it is simply supported or continuous, the same criteria, the same evaluation criteria also.
Yes.
Yeah. So is it conservative? I mean, for non-continuous beams or redundant beams, and
So
on.
the question is are the load testing methods conservative for simply supported compared to non-simply supported structures?
Yeah.
And I'm gonna answer this as my personal opinion. If you ask the other presenters in this session, you'll probably get slightly different answers. I think the acceptance criteria are a little bit conservative. I mean, I think it's relatively simple to get a simply supported member to pass the load test, and it's even easier to get something with continuity. It probably is a little bit harder now with the cyclic load testing method, but all of these load tests, if we don't load test, we always load test structures because there's a problem. It's very rare that we go out and load test a perfectly good structure. So I don't necessarily, I think that the load test methods are a little bit conservative. They do tend to, I think they are effective at identifying structures. But you're right, the continuity is definitely a big factor. I think if you want a better load test method for a continuous structure, it is the cyclic one. That's more likely where you are going to get, if you are going to get damage, I think you are more likely to see it, but that's just my opinion. I guarantee everybody else in the room has a different opinion or slightly different opinion.
Thank you. And another short question about the limit of the compressive strength of the flexural member. Is there a fixed limit on, let's say?
ACI 437.2 has a 8,000 PSI limit as a limit for the compressive strength just because they don't have a lot of experience. And I guess Mohammed, once somebody's going to talk about the database, they don't have a lot of experience on load tests of structures made with really high strength concrete. I know 8,000 is not really that high strength anymore. Yeah. That limit does not exist in ACI 318, as far as I know. And that limit is in 437.2 just because they don't have a lot of experience with that. Yeah. But it does not, I don't think it precludes you from doing a load test on a higher strength. Correct me if I'm wrong? I don't think it precludes you from doing it. It just cautions you that there's not a lot of experience with it.
Okay. Thank you.
Thank you.